Happy beginning of the semester. My name is Patricio Mendez. I'll be one of your two instructors in this class. You're lucky because this semester, and this semester only, we're going to have an anomaly that is two. The other one is a recipient of a prestigious teaching fellowship that is Ying Wan over here. So she's doing her PhD in our research group, and so she'll be learning to teach, or maybe you're going to see that she knows some already. So I would like to point you to our lead TA. Back there is with our cameraman, Dmitry Haverilov, right? He's also doing his PhD in our research group. Heat transfer. Heat transfer is, most of you or all of you should have fluid mechanics, right? All right. So this class comes right after fluid mechanics, because we're going to talk about how heat moves through things, and in part how the motion of fluids helps in the heat transfer. Now, there are two interesting things about this class. Number one is how it builds on all this knowledge that you learn either from fluid mechanics or some things that probably you happily have forgotten, like some very basic calculus and some things that you pass in physics or thermo, and you say, okay, the rite of passage is over, I'm free and clear. Well, you're going to see how in this class we use it and we put it all together. So that's one interesting thing. The other interesting thing is that what you're going to learn in this class is the real thing. So you're going to learn a lot of formulas, which you don't need to memorize, but you're going to learn lots of concepts. And those formulas and concepts are what you would use to design a real heat exchanger, a real spacecraft, a real car, a real, cook stove. This is not Mickey Mouse. These are not made up numbers anymore. This is not funny examples just for your learning. No, what you're going to be learning is things that then you can use from the same book that we recommend, and you get real values. And I'll tell you, I know this from first-hand experience, because way back in my past life, I was an entrepreneur, and we designed a machine that had to make to mix molten metal, and had to keep a given thermal balance and a mass balance. And we designed it according to the principles I'll be teaching you. And believe it or not, the machine worked out on the day we put it on the factory floor. It was running. It happens seldom, but it did happen to us. This class I asked to teach. I'm a mechanical engineer who eventually got a PhD in materials engineering, and now I'm teaching this class. For most of you are chemical engineers, right? But this class is something I really like, because we are going to start with few very basic concepts. We'll even get to the point which we get an infinitesimal cube of matter, and from there we derive the equations that will be the ones we use in heat exchangers to understand things like, why if you touch something hot, you feel it burn only after a while and not immediately. You're going to learn, for example, why if it is 20 degrees right now in this classroom, you feel it's okay. But if you dive in the water at 20 degrees, I don't know if you have done it. Don't do it, right? It's very cold. Now explain to me why. If it is, isn't it 20 degrees, right? Why? Okay, you'll know all about that. We'll talk about so many interesting things. For that reason, I asked to teach this class. And by the way, nobody else wants to teach this class, because all these things I love that it involves. I told you some of the physics, some of the math, which I love. I'm not pushing it on you, but you'll need to use some of those things. Sometimes the love doesn't come back, right? So many of my colleagues are smarter and said no, but I really love this. So I hope some of this comes across, because it's really a core part of engineering. It even helps you to understand how the dinosaurs went extinct, or why we had this huge fauna during the ice ages. At the end of this class, 4 months from now, you'll see machines in a way you have never seen them before. It will make sense to you why some things are the way they are, why they have some fins, why they have cooling channels or water running, why things are a given size. And in particular, for most of you who are chemists, when you get to your design class, you will be tasked to design a heat exchanger. And what you will be using is what you're learning here. So that's a pretty cool thing. I'm not going to teach you about the subtleties of heat exchangers, about why would you choose a configuration over the other. I'm going to teach you how you make sense, what matters in a heat exchanger, how do you design for the size, right, of the heat exchanger, how do you get the relationship between flow rates and temperature changes. So this is really cool. This class, heat transfer, it's been a few hundred years of people working on this all over the world, a few hundred years. And I'm going to teach it all to you in one semester. I'm going to teach you things that like Archimedes didn't know, Aristotle didn't know, right? Things that Newton didn't know. But you're going to know in one semester. So although it might seem that we move slowly and easy things, this is a little bit like rock climbing. You go one here, you get another anchor point here, and all of a sudden you look down and you're really high, right? This is the way the class goes. So each time you're going to come and think, not much is happening, but a lot is happening. So please stay on top of it, because the knowledge piles on top of the previous one. Calculators, I don't care about that. Okay, so this is, you have this already uploaded. What you're going to see in this schedule is that for as much as we could, we have blocks of topics. Like on 1 week, we looked into lumped capacitance, which is not a malignant tumor or anything like that, right? But spatial effects, nothing to do with Star Trek, but we have blocks of topics for each week. We'll try to stick to them as well as we can. And each of these topics is a chapter of the book. And by the end of the semester, you pretty much know the whole book.